Alright, in this video I want to go over how to solve for quadratic equations by factoring. Of course, when you take a test or a quiz, solving for quadratics is the same as saying find the solution of quadratics equations. Now we have these 5 examples that we are going to be going over. So the first example is this one, so which I wrote down here. Now before you can even start factoring any quadratic equation, what you want to do is that you want to make sure you have a standard form quadratic equation that is equal to 0. Well, in this case, you have this you have a standard form quadratic equation on the left, but then on the right it is not 0. On the right hand side it is 11x plus 5. So with the x on the left hand side and the x on the right hand side, which hand side, left or right, am I going to move all of the variables and all of the constants to, so that the other hand side can be equal to 0? Well, to determine that, what you want to do is that you want to make sure your leading coefficient, in this case it is the invisible positive 1, positive all the way through, because with the positive leading coefficient, factoring is going to be a lot easier, unlike having the negative leading coefficient. So I want to keep the leading coefficient invisible positive 1 positive all the way through. So I have to leave the left hand side alone, and I have to move all of the right hand side to the left so that the right hand side can be 0, which is the thing that I need. Subtract 11 and subtract 5 to both sides. I'm left with x squared minus 9x plus 20 equals 0. Now we have the standard form quadratic equation equals 0, so we can go ahead and try to factor this out. Well, conveniently enough, we have the invisible leading coefficient, we have the leading coefficient, the invisible positive 1, just like in the previous examples, in the previous videos. I can factor this by looking at the first term, looking at the last term, and looking at the second coefficient. So let's see. Set up a pair of empty parentheses, bring down the equals 0. Looking at the first term first, two multiplicative factors of x squared are just positive x and positive x. Looking at the last term, I want to come up with two numbers that multiply together to give me back positive 20, but also added together to give me back the second coefficient, negative 9. Well, easy. If we choose negative 5 and negative 4, negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. So hey, this is the factor form of this. So using something called the zero product property, at this step, we get to set each of these binomial factor equal to 0, and then we solve for x. So we say by the zero product property, which is something that we get to use only when we have all binomial factors like this. Take each of these binomial factors and set it equal to 0. And then in each case, separately, solve for x. Yeah, plus 5 on the left, so x equals positive 5. Yeah, plus 4 to both sides on the right, so x equals 4. So x is 5 and x is 4, being two x values that can potentially the solutions of this expression. Well, are they really the solution? Well, that's when we check for them by plugging in each of them into the original expression, the original equations. So if x equals to 5, is it true that the left is going to be equal to the right? 5 squared plus 2 times 5 plus 25 equal, with the question mark on top, 11 times 5 plus 5. Well, let's do some mental math because these are simple numbers. 5 squared, 25. 25 plus 25, that's 50. 50 plus 10, that's 60. So the left-hand side is 60. Oops. What about on the right? On the right, let's see, 11 times 5 is 55. 55 plus 5 is 60. Well, hey, because the left-hand side is the same as the right-hand side, x equals 5 is the solution. Let's try x equals 4. So if x equals 4, is it true that the left-hand side is equal to the right? So let's see, we got 4x squared plus 2 times 4 plus 25 equal with the question mark 11 times 4 plus 5. Mental math again. 4 squared is 16. 16 plus 25 is 41. 41 plus 8 is 49. 11 times 4 is 44. 44 plus 5 is 49. Well, hey, guess what? Left-hand side is equal to the right-hand side. So x equals 4 is the solution. So x equals 5 and x equals 4 are both the solutions of this expression. I don't know why I keep saying expression. This equation, my bad, because there's an equal sign. Now, what about when the left-hand side not equal to the right-hand side? When you plug in an x values that you were able to find using the same or similar procedure like this. Well, if you plug in that x value and the left-hand side is not equal to the right-hand side, then that means that x value is the extraneous solution. And it's spelled like this. Extraneous solution. Okay. And of course, if you take a look at, I think the first two videos that I did, there was some extraneous solution in those examples, okay? But the idea is that extraneous solution is an x values that once plugged in to the original equation, the left-hand side will be different than the right-hand side.